Okay, welcome everyone. In this video, we are going to revise question B of the 2024 July intake chemistry 1001 final exam. Okay, so we go straight into the solving. So the first question here, they're saying, assuming water has a density of 1.00 grams per milliliter at 4 degrees Celsius, how many hydrogen atoms are present in 6.26 millimeters of water at this temperature? Okay, so our goal is to find the number of what? Hydrogen atoms. Okay, but where are we going to start? We are going first of all to use what we have, okay, to get the molecules of water, to get how many molecules of water. And then from that molecules of water value, we can be able to get the what? The hydrogen atoms. Okay, so let's get what we have here and then we see what we can use it for. So we've been given the density there to be 1.00 grams per milliliter. Okay, what else have we been given there? We've been given the mass. Okay, so this mass here we were given as 6.26. Okay, so 6.26 grams. Okay. Okay, millimeters here. We've been given this is the volume, not the mass. Okay, so this is the volume here. So we've been given the volume of the water. Okay, so remember water has this formula, right? So we want to find how many hydrogen atoms are in this water. Okay. Okay, so what are we going to do? Okay, we are going to use this information that we have here in order to find the mass of water that we have. Okay, and then after finding the mass of water, we're going to use that mass of water to find the moles of water. And then from the moles of water, we'll be able to come up with the what? The molecules of water. And then from the molecules of water, we'll reach our destination, which is the what? The number of hydrogen atoms. Okay, so we know that density by formula is just mass divided by what? Volume. So if we make mass the subject of the formula, it means mass will just be equals to D multiplied by V, right? So let's multiply 1 multiplied by 6.26. So our mass is just 6.26 grams. So this mass now, we are going to turn it into moles, okay, by using the formula for molar mass. So we know that, for the formula for moles. So we know that moles is just equals to mass over what? Molar mass. So mass is this guy here, which is 6.26. And then we're dividing all this by the molar mass of water. So what is the molar mass of water? Okay. The molar mass of water is just 18.02. So you add the molar mass of oxygen, which is 16, plus 2 of the molar masses of hydrogen. So it will be 2 multiplied by 1.01. Okay, so multiply this and then add the 16, we get 18.02. Okay, so let's divide this in order to get the moles of what? Water. Okay, so 6.26 divided by 18.02. I'm going to get these as my number of moles, 0.34479178 So these here are my moles of what? Water. These are my moles of water. So from these moles of water, what am I going to do? I'm going to change those moles to number of molecules. Okay, we're going to change this number of moles to molecules. So how do we do that? Okay, so by the Avogadro's constant, we know that 1 mole of anything contains how many molecules? 6.02 multiplied by 3, okay, multiplied by 10 to the power 23 molecules. Okay, so this is by definition. 1 mole of anything contains this number of what? This number of molecules. So here now we have these moles here. So we are going to say, what about 0.34739178 moles? How many molecules of water are we going to have here? Okay, so you cross multiply, so it will just be x is equals to, okay, this number here multiplied by the Avogadro's constant. What are you going to get? Okay, so I punch this onto my calculator. I'm going to say multiplied by 6.023 multiplied by 10, okay, to the power 23. Okay, so what am I going to get as my number of molecules? I'm getting 2.09 multiplied by 10 to the power what? 23 molecules of water. Okay, so these are molecules of what? Of water. Okay, and then from here, since we now have the molecules of water, okay, we now have the molecules of water, to be very easy for us to find the number of what? Hydrogen atoms. So remember, if I have one molecule of water like this, okay, so this is one molecule of water. How many atoms of hydrogen can we see from this one molecule of water? Okay, we see that from one molecule of water, we have 2 hydrogen atoms. Okay, we have these 2 here, 2 hydrogen atoms. So what about in this number of molecules? How many hydrogen atoms are we going to have? Okay, so I'm going to write this 2.09 times 10 to the power 23 here. So these are molecules of water. And then I'm going to say equals to X atoms of what? Hydrogen there. So let's multiply. We're going to have X here, and then 2 multiply this number. So multiplied by what? 2. Okay, so from that, I'm going to get 4.18 multiplied by 10 to the power 23 atoms of what? Hydrogen. Okay, so this here is our final what? Our final answer. Okay, let's look at the other question now. So the other question now is saying, we are on question B here. They're saying an auto mechanic, okay, an auto mechanic spills 80 millimeters of 2.6 molar sulfuric acid from a rebuilt auto battery. How much sodium hydrogen carbonate with a molar mass of this guy must be added on the spill to react completely with the sulfuric acid? And then they have even given us the chemical formula here. So this sulfuric acid is reacting with what? With the sodium hydrogen carbonate to produce whatever we have here. So notice that this chemical equation here is already balanced. Okay, it's already balanced. So what must we do in order to find how much of this sodium hydrogen carbonate must be added to that acid that has spilled on the ground? Okay, what do? We use the mole ratios, okay? So we know that we've been given the volume and the molar mass, the volume and the molarity of this sulfuric acid, right? So using the molarity and the volume, we can find the moles of this sulfuric acid, okay? And then after finding those moles of sulfuric acid, we're going to get a mole ratio from this equation, okay, for the sulfuric acid and the sodium hydrogen carbonate, okay. Then from that mole ratio, we're going to come up with the moles of these. And then since we have the moles of these here, okay, we have the moles of these, we are going to use this molar mass here to find the mass of this guy here, okay. And then we'll be done like that, okay. So let's find. Okay, so let's find the moles of this guy here. Let's find the moles of this guy. Okay, so we are going to start with what we know, okay? So we know that we have how many milliliters of this sulfuric acid? We have 88 milliliters. So we have to change this 88 milliliters to what? To liters. So we just divide this value by 1,000, okay? So I'm going to say the volume of the sulfuric acid, okay, is 88 milliliters, but you always change these to milliliters to what? To liters. So you divide this by 1,000 like this. Okay, so when we divide these, we are going to get 0.088 liters. Okay, so this is the volume, and then we have the molarity of the sulfuric acid, which is given by 2.60. Okay, so all these are for what? Sulfuric acid. So from these two, we can come up with the what? The moles. Okay, so from these two, we can come up with the what? With the moles. So we're going to say moles is just equals to MV. Okay, molarity multiplied by what? Volume. So moles is equals to our M is 2.6 multiplied by our volume, which is 0.088 liters. So punch this on my calculator to get the number of moles. Okay, so if I multiply this and this, I'm getting 0.2288 moles. So these moles that we found are moles of what? Sulfuric acid. Okay. Now, when we go back to this equation here, we see that we can get the mole ratio for the sodium hydrogen carbonate to the sulfuric acid. We see that when we have one of these, then we need two of these. So the mole ratio there will be 1 to 2. Okay. So that mole ratio is going to help us find the moles of the sodium hydrogen carbonate, this guy here. Okay. So let's get the mole ratio. So the mole ratio is 1 to 2. Okay. So here you have sulfuric acid. And then there you have the what? Your sodium hydrogen carbonate. Okay, so now from these moles here, we have 0.2288 moles. And then we're going to say to X. Okay, and then we'll do a cross multiplication. So X multiplied by 1 to be X is equals to 2 multiplied by this guy here. What are we going to get as our answer? Okay, according to my calculator, I'm getting 0.4576 moles of what? Sodium hydrogen carbonate. Okay, so remember the question was asking us how much of this sodium hydrogen carbonate should we add? Okay, so since we have the moles here, and in the question we've been given its molar mass. Okay, its molar mass was let me check here. Okay, we've been given its molar mass as 84.02. So I'm going to write my 84.02 here. Grams per mole as its molar mass of this guy. So we have its moles and its molar mass. So we can be able to find the what? The mass that will be added. Okay, so let's find the mass. So we know that moles is equals to mass over molar mass. So now cross multiply, we are finding this mass. So mass is just equals to moles multiplied by what? Molar mass. So the moles are 0.4576 multiplied by the molar mass, which is 84.02. Okay, so punch this onto your calculator. We are getting 38.4 3 grams of sodium hydrogen carbonate. Okay, I've forgotten an A here. Okay, so this here is the amount of sodium hydrogen carbonate that should be added. Okay, that should be added to that solution for it to be neutralized. Okay. Okay, so that's how you find that one there. Right. Okay, now let's go to question B3 here. Okay, let's go to question B3. So question B3, we have this question here on mass and mass percent, and then we have this one on titration, dilution, I mean. Okay, so the first one here, they're saying calculate the molarity, okay, of a 20% potassium iodide solution with a density of this guy, okay? And then they are telling us that the potassium iodide has the molar mass of this much, okay? So calculate the molarity. So we know that molarity is just concentration in moles, right? Okay, so molarity is equals to moles divided by what? The volume. Okay, so first to calculate this molarity, from the given information here, we have to find the moles, and then we have to find the volume, and then just divide them like that. So how are we going to find these moles, and how are we going to find this volume? Okay, so the key is here. So when you see a 20% of something, just know that that is a what? Mass by mass percent. Okay, so this 20, let me write it here. So this 20% of potassium iodide, okay, is what we call mass divided by mass, or by mass percent. Okay, so this is what we call mass by mass percent. So mass by mass percent is found by this formula. Okay, mass by mass percent is found by this formula. Okay, so mass by mass percent will be equals to, let me write it like this. Okay, so mass by mass percent, it has this formula of mass of the solute divided by the mass of solution. Okay, so now this solution here is made up of two things. It is made up of the solute, and it's made up of the what? Solvent. So this solvent is just water. And then this solute here is this potassium iodide, or whatever you'll be given here. That's the solute. Okay, so it means this 20%, okay, this 20% here was found after they divided the mass of the solute divided by the mass of the solution, okay? And this mass of the solution is just the mass of the solute plus the mass of the solvent. So what this 20% actually mean, this 20% potassium iodide, okay? That 20% potassium iodide here means that we have 20 grams of potassium iodide, okay, being dissolved in 100 grams of the solution. Okay, we know that 20% is the same as 20 over 100, right? So it means here of the 20, and then here of 100. And this will be my 20%, which is this 20% mass by mass percent. Okay, so it means I have 20, the mass of the solute, and then 100, the mass of the what? Solution. So this is what I have. Okay, so from this mass of the solvent, okay, we are going to find our moles. And from this mass of the solution, we are going to find our what? Volume. So this is what we are going to do. Okay, we are going to divide this board into two. So I have the mass of this potassium iodide as 20 grams. Okay, remember I was also given the molar mass of this guy as 166 grams, 0.0. Okay, 1.66.0 grams per mole. Okay, and then here the mass that we are dealing with is the 100 grams of the solution, and then remember that we were given the density here, which was 1.2012 grams per milliliter. Okay, so from here we are going to find the moles. Okay, then from here we're going to find the volume, and then once we have the mass and the volume, we're just going to put them in which formula? Where was that formula that I wrote? Oh, I wrote it on the first page here. This one's here. We're just going to put it there, put the volume there, and we'll be able to find our molarity. Okay, so now let's find the moles. So moles is just going to be equals to 20 divided by 166. And then here, density, we have the mass. So what is the volume? Okay, we know that density is equals to mass over volume. So let's make volume the subject to the formula. It will be V is equals to mass over density. Okay, so this 20 divided by 166, what is it going to give us? So let's find. Okay, so 20 divided by 166, I'm going to get these as my moles, 1, 2, 0, 4, 8, 1, 9, 2, and then 7, 7 moles. Okay, so these are my moles. And then let's find the volume. Yeah, so volume is going to be equals to mass, which is 100, divided by the density, which is what? This guy here. So 1.2012. So this will be equals to, so we have 100 divided by 1.2012. Okay, so we're going to get 83.25 milliliters. Okay, so now we have the moles and the what? The volume. Okay, so we can find our molarity here. But remember that for us to find our molarity, our volume always has to be in what? In liters, because this is milliliters. Okay, so we have to change that volume to liters. So what do? Just divide this by 100. So molarity is equals to moles divided by volume. So I'm going to write the moles here. Hey, what's happening to my pens? Okay, so 0 point, I'm going to say 1204819, that whole number there, and then divided by the volume, which is this, but I'm turning it into what? Liters. So 83.25 divided by 1,000. Okay, so this is going to give us what? So let's divide this. So we have 0.1204819 divided by 83.25 divided by 1,000. Okay, so I'm getting 1.44723003 as my molarity. So I'm just going to say this is the same as 1.45 molar, okay, of potassium iodide. So this is how we find the molarity. Okay, so we go step by step. All right, and then let's look at the last question now. Okay, for section B. So section B, last question, they're saying how much water would you add, okay, to, how much water would you add to 146.8 milliliters of 2.81 molar potassium permanganate solution to prepare 0.875 molar potassium permanganate solution. Okay, so this is just dilution. Okay, this is just dilution here. So we're just going to use the dilution formula, which says that M1 V1 is equals to what? M2 V2. Okay, so this one here is our V1, it's our initial volume. Then this here is our M1, our initial molarity. And then this here is our final molarity, which is M2. Okay, so the M here is to first find V2. Okay, and then to find how much water was added, we are going to subtract V2 minus the initial what? Volume there. So let's find. Okay, so we had M1 to be equals to 2.81, and then V1 was 146.8 milliliters. KM2 was given as 0.875 molar. Then V2 we do not know. Okay, so we want to find this V2. So our formula is M1 V1 should be equals to M2 V2. So we want to find V2. So we can make V2 the subject so that we have M1 V1 divided by what? M2. Okay, so let's find our V2 is going to be equals to, we just substitute the numbers there. So 2.81 multiplied by 146.8 divided by, we have 0.875. Okay, so V2 is just going to be equals to, punch this on our calculators. Okay. Okay, so when I punch this, I'm getting 471.65 milliliters as the new volume. Okay, so now to find how much water was added, okay, we are going to say water added. We'll just subtract V2 minus V1. So V2 minus what? V1 to find how much water was added. So V2 is 471.65 minus V1, which is 146 point, where is that much? 0.8. Okay, so the water that was added, just subtract these two. I'm getting 324.85 milliliters. Okay, so thank you so much for attending. This is where our lesson ends. And don't forget to register for our extra lessons. Okay, all right, have a blessed day, guys.